Okay, got a request for this question. It's from EDEXCEL Unit 1 in AS Physics for the summer 2014. Question 14 of that paper. A student rows across a river heading from point A. Her boat is headed in a direction at right angles to the bank, and she rows through the water at a constant speed of 1.5 meters per second. The river flows with a current of 1.1 meters per second. Calculate the velocity of her boat relative to the riverbank. So what's going on here is that she does this and the river does that. So her overall behaviour will be the combination of 1.5 that way and 1.1 that way. So this vector added to this vector gives a resultant velocity that way. Okay, so that's what you're doing here. And so that velocity will have a size, a magnitude, and a direction. And we're going to take the direction to the riverbank, so we'll take it to the horizontal. So there's going to be an angle in here that we're interested in, and that angle is going to be tan to the minus 1 of 1.5 over 1.1, because this is the opposite and this is the adjacent. And the magnitude of this resultant is going to be the root of 1.5 squared plus 1.1 squared. Okay, so you can check the mark scheme for the values of those, but that's how you're going to get those two. Fair enough. So another student tries something different. They row at 1.5 in that particular direction, and the river continues to flow at 1.1 meter per second. On the grid below, draw a scaled vector diagram to determine the velocity of the boat. So again, you have to add these two vectors together. You're adding a vector like that to a vector like that, and you're going to get an overall resultant vector. You've got 1.5 like this, 1.1 like that, and we're told that it's 65 degrees to the riverbank, so we know that angle. And so they give you a grid squares to allow you to measure these out, and you basically use your ruler and the grid squares as your guide to put in these two vectors. So you look at this grid and you decide on a suitable size for that. You know your second vector is going to be purely horizontal, so you're trying to fit in the biggest 1.5 that will still allow you to draw the 1.1. So that comes down to a choice of scale. You know, if you draw something ridiculously small in the top, you're going to be not as accurate as if you draw this as big as it can possibly be. So at this point, you will need a protractor, and you will need to measure out a 65 degree angle, and that will enable you to draw this out. So I've picked a starting point here. I'm going to place my protractor on that starting point on the grid lines, making sure the grid lines are lined up correctly. I'm going to find 65 degrees, 60, 65, 70, so that's going to be here. And that's going to be the direction of my first vector. It's going to run along that line. So I need to decide on a suitable scale, and it has to be 1.5. So I'm going to decide on 5 centimeters to represent 1. So that will mean this will be 5 and a half of 5, which will bring me up to 7.5 centimeters, which is going to take me to here. So my first vector is 7.5 to there. I then need to go 1.1, and 1.1 is going to be 5 and 0.1 of 5, which is going to take me to 5.5 centimeters over here. My iPad is getting in my way here. So I need to measure along this line to the 5.5 mark, which is going to be here. And that's my second vector. So this is 1.5 to scale, this is 1.1 to scale. My resultant is going to be my start point to my end point. I've got these tip to tail, so these vectors have been added diagrammatically here, which means my resultant looks like that. How do I turn this back to a vector? Well, I measure how many centimeters it is. And on my scale here it's 11 centimeters. Now how many 5s is that? That's 2 5s, and 1 centimeter is a fifth, so that's working out 2.2 meters per second. I also need to measure its angle to the riverbank here, so I get my protractor on the riverbank with 0 degrees on the riverbank, get these grid lines lined up, and then I try and measure this, and I reckon that that is 38 degrees to the riverbank. It's 40 here, 2 back.